Hi, and welcome to exercise number 4 of our series of DFlow FM exercises. In exercise number 4, we will create a model that is able to simulate tidal hydrodynamics in a Western Scheldt. So based on the net and the bathymetry that we made in the previous exercise, we will make such a model. So to start with that, we open Delta Shell again with an empty project. We're saving as exercise 4, like so. Okay, so we start by adding a flexible mesh model again. And as before, we load our land boundaries and our grid. There we go. So we can have a look at the bed level, like so. So this is the bed level we had before, except for the fact that the harbor is still dry, but it doesn't really matter for this this exercise. So we're going to start with this setup, and we are going to add the boundary conditions as were given in the assignment. So what we have to do then is we gonna add two open boundaries, so one on this side and one on this side, and this one will be a water level boundary, and this one will be a discharge boundary. So here we have the tides from the North Sea entering the domain, and here we have the river flow entering the domain from this side. So how do we do that? First of all, we're going to add two open boundaries. We can do that by using this icon here in the upper left corner. I'm going to zoom in a little bit, and we're going to click a polygon along this boundary, like so, and make sure that if you make the outward projection from your cell towards the polygon, that the two extreme cells for sure cross this polygon, because at the initialization phase of FM, what actually happens is that a imaginary line is drawn from this cell center outward, and if it encounters a boundary polygon, then this cell is marked as being a boundary cell. So it's important that this polygon covers the entire open boundary. So that's for that one, and now we have to do the other one. So the same story here. Click and finish by double clicking. So you see that we have now two open boundaries added to our model, and to those open boundaries we can now add data. Okay, so we can double click these, and that will open a new window that shows us the geometry as we have drawn it. It's a flow boundary, and this is the seaward side, so we actually are going to impose water levels. So we can click add here, and the assignment tells us that we have to add a tidal boundary using astronomic components. So we have a constant value of plus half a meter NAP, and then on top of that we have an M2 tide of 1.25 meters amplitude. So we're going to specify those series, and we also have to specify where these conditions are going to apply. And if you have a boundary with multiple support points, then you can assign the same signal over the entire boundary by converting these green pluses of the first and the last point, and then it will nicely assign the same signal to all these support points, and so you have a constant, spatially constant boundary condition along the whole boundary. Okay, so we have set which sort of signal, we have set where it's going to be applied, and now we have to add the type of signal we're going to specify. So that's going to be an astronomical signal, and we can fill that out in this table here. So here we have a drop-down menu with the appropriate components. So we have a constant offset of 0.5 meter, so we specify that with the A0 component, which basically means a constant signal. So that is 0.5 meter, and you are also asked to add an M2 semidiurnal component, which you can do here, of 2.5 meter total, so amplitude of 1.25 meters. And here I choose to have a phase of 90 degrees, because you can see in the plot then here, if I do that, that my signal at the start of my model will nicely start at 0. So I don't have any spin-up issues where my boundary would be out of line with my initial condition. Okay, so I can save this project, and then it will save all the relevant files, like so. Now we can do the same thing for the second boundary, which is a discharge boundary this time. So we're going to add a discharge boundary. It's a constant boundary, so again we can use as either astronomical ones with the A0. That's maybe the easiest. We know it's 2,500 cubic meters per second. And we are going to add those why don't I have a nice yeah. And as we are having a total discharge, we don't have to specify this over the support point. Okay, we're going to save again, like so. All right, so that is everything that concerns our boundary conditions. So now you can see that we have a signal here, and we have a signal over here. Okay, you can see that with these little figures here. Okay, so we have boundary conditions, we have a grid. Now we have to set all the other parameters of the model. We can do that by double clicking General. So that will give us the tab where we can set all our other parameters. The latitude, well, we're about 51 degrees north. We only have one layer, so this is a 2DH model. We are going to run this model for, let's say, 5 days or so. That'll give you about 10 tides, which should give us a nice spin up and a good view over what the tidal dynamics look like. Then we can go to the processes tab. We're not gonna model sediments or salinity, and we're not gonna couple with waves, so we can leave all these as they are. I am gonna change my initial water level to plus 0.5 meter, because then it's nicely in line with my boundary conditions and I have less issues with spin up. For the physical parameters, I am going to let everything as it is at the moment. That looks okay. Yeah. We don't have wind, so we don't have to specify anything here. Also, numerical parameters are okay. Then we arrive at the output parameters, where we can actually indicate what we want to save from the model. By default, a lot of these things are turned on, but that's not necessary. So basically here we are interested in the water levels and the velocities. So we can switch all of them off and then switch on only the relevant ones. So we want the water level, the water depth, and we want the velocity vector. Okay. So that's for the observation stations. And then for the map file, we're also gonna switch off almost everything. And we are only interested in the water levels and in the cell center velocities. And all the rest we don't need. So we're gonna have an output every half an hour. And for the history file every 10 minutes or so. And then it's important in FM to have the output time steps. Those should be multiples of the user time step. So here my user time step should be either 5, but I think that 10 minutes is okay. So the user time step is the frequency with which the boundary signals are being updated. So that is okay like this. Here you don't have to change anything, and neither do you have to do this here. So we can save all this because we are done. Now, when we close this, we can go to home and select our Flow FM model and then say run current, as I asked you to do before. And if all is well, this is going to run. And this takes about 1.5 minutes to finish. So in order to have the results ready when the model has stopped running, we save the project, and that'll save the output in the project data folder. So we can see that here. So we have an output folder which has our map file, and we can either choose to visualize these results within FM, or we can use something like QuickPlot, as you did with the Delph3D4. So for example, if I would do that, I can open QuickPlot here. This is basically the same QuickPlot as the one you have with your Delph3D distribution. And now I can have a look at the water levels, for example. Continue shades, like so. Up. And now I can make a little animation of this. Tube. Which would actually be better if we fix the color limits to the tidal range that we had. So let's say +2 and -2, because we have tidal amplification in the estuary, like so. And we have an offset of 0.5 meter. Don't forget that. finally. That's good. Like so. So if we now start this, then we see a tidal wave moving up the river and flooding the shoals, ebbing again, and so on. So our model seems to be working, which is nice. So that concludes our video on setting up a model in Delta Shell. Well, I hope that you managed to reproduce this. See ya.